This is Smokeless Chimney, where we use the scientific method to determine that size matters. The best flames on the net. I like to look at bright, luminous flames. We need to have bright, luminous flames that generate the least amount of smoke. We have found that to do that, if you use smaller fuel packages, you will generate less smoke. Stay tuned for the details. We noticed this stack was smoking, so I went to break down the material, and this large piece of wood had not charred through enough to break down. We had nice, bright, glowing coals, however, couldn't break down the material, so it continued to smoke. A rather stubborn problem. This is our opacity monitoring device. It is a prototype, and it has a lot of gangly wires, but it's working very well. You'll see graphs coming up. It's using about 6 watts to turn the fans and operate the light. The color shift for the 48 hours, the large logs are to the 0 to 5 hour time, and the small chunks of material are the second. In the yellow, we have the small chunks of wood, some of them slotted. In the green, the large. This is the opacity chart for both tests. The large logs, the large fuel packages, 0 to 5 hours, and the small is the 20 to 35. You can see that there's far more time above the 20% with the large material, and we have small excursions above 20% with the small material. Definitely different in my eyes. I hope you guys can see the same thing here. Very detailed graph. I've split the two charts up so you can compare them. The upper chart is the large fuel chunks, and the lower was when I used small fuel chunks. You can see that the small fuel chunks have significantly less area above 20%. That's the fire that I did during this test series. Nice, bright, luminous flames. A little later, I was able to break down the material. It had charred through to the point where it was simply just carbon. Look at those beautiful coals. Nice, bright coals. That's what I'm getting when I use a combustion air fan. At this stage of the fire, the fuel produces very little smoke, but it does help to break it up so that you can fit more material in it and you expose new surface area. These are the temperature recordings from the two tests, the top one being the large fuel pieces, the bottom being the small fuel pieces. We can see the stove shell, the gas temperature, and the fan. And the little piece of pellets I put in is that last little blip. During the day, I measured over 500 on my PM 2.5. This is out in a shop. This would be very uncomfortable in a home, but occasionally wood stoves puff, and I wanted to show you a way of making a large piece of wood smaller. You don't have to cut all the way through it. I put scores in it about every 2 inches, and it behaves like a small piece of wood. It increases the surface area, and it chars through the material, and you'll be able to break this up faster than if you had not performed this. It was rather cold on this day, and having a wood stove to keep the house and the shop warm were quite pleasant. This is the prototype. Now, is this smoke or condensation that you see in the upper left? I say it's condensation because you don't see it at the chimney, at the exit of the chimney, and my instruments don't read it. Smokeless Chimney, www.smokelesschimney.com, Facebook, Reddit, and YouTube.